Hey, hello, folks online, folks in the room. How's everybody doing tonight? Welcome to our October meeting. Great to see everybody here. And there is a sign-in sheet going around. If you can sign in when you see it. I guess it's by your elbow, Colin. If you could see to it that that sign-in sheet goes around. Then very good. And Colin's going to admit folks that are coming in online. Great. So we're going to do a couple of main things, but of course we always like to hear about projects that people are working on and things like that as well. And during the second half of the meeting, Bill is going to talk to us about his lithium batteries that he's got up here on the card. So welcome everybody. We are using the computer room for the first time, which I'm really happy about. It gives us more space than the small classroom. And we had a really good event for National Drive Electric Week here in Houston, or I guess rather in Bel Air. And thanks to everybody who brought cars out and talked to all of the public. And thanks to Colin for bringing out the go-kart that lots of folks had fun zipping around with that go-kart. And we had some folks from Evolve Houston here, and one guy brought his little electric skateboard. And so he's showing folks how that worked. And of course, we had folks with Mustang Mach-E's, and they were all, of course, really happy to show us their front trunks or frunks that had cold iced drinks in them and everything. In fact, it's kind of funny. I just read an article day before yesterday that Ford has now officially given up calling it the front trunk. They have now agreed to call it a frunk, because that's what everybody knows an electric car has when you open the front hood and you have empty space in there, that it's a frunk. So Ford has gone for that officially now. And of course, there's lots and lots of other news. I won't go into things. I'm sure folks are reading things. But at our event there at the elementary school, we met Sagar, and he and his, is it family that have the company? Family members that have the company. All right. And it's really good to hear about the technical things that his company is getting involved in, because as he and I talked about there, the most important thing is to pre-wire construction like apartment buildings and things like that, so that the charging can be put in, because of course, owners of existing apartment buildings are loath to spend money on something that they don't see getting a return on. So the best way to do it is put it in when it's being built. So you'll hit upon that along with some other things. You got some slides here. So I'll hand it over to you and take it away.
Thank you, Dave. Thanks for the gentle introduction. Good evening, folks, both online and in person. I'm honored to be here. I was fortunate to run across Dave a couple of weeks ago, and I was gracious enough to invite me over here. So I think what my plan is to give you an overview of what we do, some of the technical stuff around the infrastructure that we are part of, kind of explain, and then listen to your questions and get some feedback and sort of be informal about that. Okay. So let's get started. Let me see if I can advance this. I think we need to go back to this window. Let me click it. Yeah, there you go. So who are we? So we are a charge point operator, or in the EV industry, we're called like a charging owner operator. We started about 5 years ago, mainly providing services in the embedded engineering electronics space. We designed control systems for chargers, more on the residential voltage capacity, like L1 3.3 kilowatt. And then we graduated into large scale 100 kilowatt charging systems, where we are helping OEMs design the electronics behind that. And then that sort of set us up for what we saw as the EV wave coming in the US. So we decided to sort of pivot off from a service provider of electronic systems to more of a operator of charging infrastructure, because we noticed that there's a big gap of infrastructure for the rest of the cars, I would say, other than Teslas. And Tesla have their own proprietary network, but the rest of the cars don't have a good charging infrastructure. And we saw a gap and we decided to sort of fill that in. So, so that makes us officially in the ecosystem as a charge point operator. And because we organically came from, developing the electronics, the power circuitry, and all that related to the charger itself, we have the capability for engineering, supply of equipment and the charging equipment, as well as installing and running them through the design life and maintaining that. So we do a full service portfolio, I would say, anywhere from design, site engineering, all the way up to the service life of the infrastructure is done, which is typically 10 years for these systems. And we're based out of Pearland. We got offices on Richmond Avenue near Westheimer. Been in Texas for 15 odd years, so native in Texas. And we are also expanding to other places. We got a couple of projects going in Colorado. So we got a registered office there as well. So we're trying to expand to other states where EVs are a lot more, further than Texas. So that brings us to the next slide. So if you look at some of the portfolio of offerings, we provide as a turnkey service provider all and everything related to charging infrastructure. So that includes anywhere from site assessments, engineering, permits, and getting in basic permitting and stuff that needs to be put in place, whether it is for an open lot or if it is apartments or gas stations or residential campuses, things like that.
Well, folks have said that they've been able to hear us online.
Do we need to press something?
We're just not putting it out of the speakers in the room. That's for the folks that are on the Zoom call.
Okay, thanks for that.
Yeah, you're speaking to the folks in the room.
Right. And the online. Okay, yeah, I'll do that. So anywhere to do with the engineering side, the pre-feed, all the upfront stuff that needs to happen. So we sort of provide that as a service. And once the infrastructure is put in place, we work with different OEMs, ABB, Siemens, all the different OEMs across different ranges of the chargers. And we provide that infrastructure. Once it is put up in place, then we also do all the operation of it as well as the maintenance of it. We have a backend software that helps us manage this charger infrastructure, or the fleet of chargers at different sites, different properties, and also we are capable of providing the maintenance around that infrastructure. So we typically own the infrastructure in all the projects that we go in. And that's why we're able to come out and just provide charging as a service, because we take care of all the engineering to the maintenance cycle on these assets. So I mean, you guys are familiar folk with EVs. I don't need to sell you guys how the chargers look like, but that's just a typical cluster of chargers. We're more interested in a group of chargers because our philosophy is, we want to address the range anxiety problem. And usually when you're going into a project, it's a lot more economical to put in more than one. And not just for a project economic standpoint, but also for the society and the EV drivers as such. One charger is not going to be enough. We're not looking for today. We're looking for 10, 15 years down the road. And we definitely feel a cluster of chargers is where you want to have more bang for the buck. And that's the thinking behind the projects that we undertake. So that's just it's like anywhere from Tesla chargers to high voltage chargers. We're capable of putting it on the ground and running it successfully. So that kind of teases us to who we are and what we do now. So what I would like to do now, go into is a little bit of background scenarios as to what is happening in the regional area, Texas and Houston, and sort of touch upon those points. So if you look at the Houston area as such, the cities have all gotten together, and there's a clean cities initiative. And Houston's mayor, Mayor Turner, he's one of the champions for clean energy. And Houston has come out, thankfully, with a goal which Evolve is part of it. The Evolve is the execution engine for the Houston's clean energy initiative. It's actually done by four major leaders: City of Houston, Shell Energy, and University of Houston. So these are the four major, leadership players for the clean transportation, for putting the clean transportation goals into practice. And Evolve is the execution engine for that initiative. So what we are seeing is there's going to be about 6x growth in the EVs by 2030, and coming up by mid 2015, 2013, sorry 23, about two times. So definitely it is in the right trajectory of multiplying by a larger percent. And we also see the number of vehicles, that models that are coming in. I think by this year we already crossed 100 models across US. Next year we're going to see a lot more models coming into the marketplace. So definitely there is push from the automakers, and we also see that validated by the amount of investment that's going into these into the sector. Billions of dollars are going in, both from a R&D technology standpoint, as well as for facilities to produce these cars at a much larger pace. So I think Tesla did a great job in leading the pack, but now the pack has woken up and everybody wants to run now. So what that means is a lot more vehicles are going to be up on the road, and a lot of investment and a lot of energy is being pushed into this space, and also supported by the federal government initiatives that are happening in the transportation sector. Another graphic that I got from this I don't know if it's a government entity or Atlas Hub. You probably guys might know about this. They do a beautiful job of putting everything around EV statistics on the web. And this is a good graphic that talks about what is happening with the vehicles side of things. So if you look at now I get to use the little spotlight. So if you look at the colors there, basically the colors represent the manufacturer, right? And if you look at maybe last year, like 2020, and even before, if you look at the blue across this entire thing, the blue is Tesla, and you can see they have lion's share, but it's fairly static. But what is interesting when I see this graphic is the rest of the colors seem to sort of grow in tandem compared to the blue. That means the other manufacturers are now picking up. The Tesla share has not gone down, and it has not grown up significantly where it's pushing the others. But what is happening is they're maintaining their share, but the others' share is increasing. Ford is pushing a lot of dollars into this industry. GM, Audi, and they all have made commitments, and that's very interesting. So I mean, it's not just the automakers making announcements and promises, right? But you can see the facts reflected in what's happening in reality with the number of EV registrations that are that. This data comes from number of EV cars that are registered in state, and you can see that. An interesting thing is almost 5% of total car sales are now EVs, and that's subjected to growth now. I mean, expected to grow. So I mean, if there are any skeptics out there, and I don't think this group has any skeptics, but it's here. It's here to stay. So with this background in the EVs itself, what is the problem, right? The big gaping problem is, or the opportunity that we see is the lack of infrastructure for these cars or for these manufacturers. So Tesla is a proprietary network. Tesla has a very beautiful, very good charging net, supercharging network across coast to coast. They've thought that through. However, their network is proprietary and their connectors are proprietary. The rest of the world or the rest of the OEMs use a different SAE connector, which you all probably know, the J1772 connector, which is good because they have standardized on that connector, but there are not sufficient chargers of that connector or that network out there. And what that means to an average EV driver or average automobile driver who wants to own an EV is, oh my God, do I buy this? What if I run out of juice on the road? I don't want to get towed and things like that. Right? It's common. I would think about that also. So that is the problem we are trying to solve. So our problem statement is we want to reduce the range anxiety by increasing the charging infrastructure for the J1772 connectors. We're not against Tesla, but we want to play a bigger role in the J1772 and the CHAdeMO CCS connectors. In that world, we want to play a bigger role. So let's see. That's all right. That's all right. So when we looked at the range anxiety problem, because that's the number one problem that's preventing more drivers to own EVs, there are a couple of solutions. It's not just charging infrastructure, right? But charging infrastructure is by far the biggest answer. There are also other solutions, which is to increase the range of the battery itself. And you can sort of see that with Tesla batteries, because Tesla don't own the batteries. Their batteries are made by Panasonic, and Panasonic has bigger design that's come up. And so that's one way to increase the range of the vehicle itself. And there are subtle improvements that the OEMs can do on their battery management systems and things like that. And then, of course, the other technology is battery storage technology and the swapping station technology. Now, that technology is not prevalent in US. We worked on a swapping technology in Asia for a couple of clients, but it's just not feasible in US market because of weight limitations and things like that. So by far for US market, the single solution that helps with range anxiety problem is having an extensive charging infrastructure. So that's kind of the landscape as to what's happening, what was the problem we saw, why we wanted to do what we wanted to do. So what is it that really we do? So what we really do is we work with property owners and we see if they are interested to have charging infrastructure on their facilities, and we come in and install and maintain and operate that equipment. That's what we do. And where are these properties and what kind of properties we typically work? We don't discriminate. Anywhere from an undeveloped property all the way to a developed campus, hospital campus or retail or even hotels. We have projects that we work, that we have going on. And the trick to putting what charge, I have a couple of slides down in my presentation, but not all properties need the same charger. Usually it's a function of how much time a typical driver might spend in a particular property. And we sort of work out the economics and what makes sense there and things like that. But the bottom line is, if someone asks what is it that we do, we put up infrastructure at the properties and provide charging as a service. So that kind of brings me to what are all the different pieces. It starts off with system engineering design all the way till supply of hardware that is the right hardware for that particular property. And then of course installation is commissioning, digging, construction, and things like that, and then letting them run. We only work with networked chargers, not so much with non-networked chargers, um, because we want to know what the health status is and we want to be able to react, and networked chargers give us that capability, and not non-networked don't. So we're sort of picky in that sense, but that's just the way of how these networks are happening nowadays. And usually we don't normally hear or see the behind the scenes effort that's involved, but there's a lot of engineering and upfront permitting work that needs to happen. And for a typical property owner, we make that seamless. There's system engineering that needs to happen because usually buildings that are already built, they have not considered these charging loads in their load schedules. So we have to work with the architect to figure out what it is. If we add 3 chargers, what is it going to look like? We're going to have to figure out the utility upgrades that need to happen and things like that. And is it, if it again depends on the property. If it's a hotel, you're probably good with level 2, but if it's a gas station, you're talking about DC fast, it's a different type of setup and things like that. So a lot of engineering that happens upfront. So we take care of that. And then also with the permitting, we have to work with the city and get the right permits, inspections, things like that. There's a big problem with the supply chain right now, as you guys might have heard and known in other areas. Supply chain does also affect the chargers. Depending for the DC fast, there are some things that are happening, but in the grand scheme of things, we try to, we run this as any other construction project. Once everything is said and done, we sort of order materials when we need to order and things like that. And then we also have our backend software, which, like I said, all these chargers are connected chargers. We know at any given point what the utilization is, how much kilowatt hour is being dispensed, is it on, off, are there any faults coming up, diagnostics. We know in and out of what's going on with those chargers. And we provide reports to the property owner or other entities who are interested in sort of. And we also have these chargers put up on PlugShare, so it's easier for the drivers to find out where they are, things like that. And of course, then the last piece is about maintenance. We have, we follow the OEM's recommendation. DC fast, there's a lot of maintenance, but for level 2s, not that much maintenance. They are fairly, robust, and these are robust pieces of kit. One would be surprised how robust these chargers are, in spite of the technology that is in there. DC fast are very complex pieces of kit, but they are very very robust, and they all have a very well defined. These are all mature products by now. I think these chargers have been in industry for more than 6-7 years now, so they're all fairly mature. And this was a slide, and you guys might have seen these slides. What kind of charger is good for what property? Usually is a function of where these properties, where these charges are going into. Single residence, L1's good, but if it is fast charging, like in a gas station or an interstate highway, people don't spend more than 10-15 minutes there. So the DC fast is a good choice there. But for the 80% of the projects that we see, level 2 seems to sort of fit the bill. It traverses across many different locations, hospitals, hotels, retail, and those kind of properties. But we're seeing big uptick in the DC fast side as well. People don't want to wait. End of the day, you want to come in, plug it, charge, and go. Let's see. So like I said, our general thinking when we get into these projects is to always think in terms of a cluster of chargers or a group of chargers, mainly because of the work that is involved in putting all this up and its ability to solve range anxiety. You want to have multiple car chargers getting charged. Typical setup would be either to run off of a different meter, get a new meter on the property, or connect to the existing meter that the developer has. Of course, some 9 out of 10 times it requires transformer and utility upgrades. So we sort of work with the utility to take care of that. And some projects we that are where the buildings are not yet stood up, we get in and pre-wire the conduit. That gives us some safety net. And we also always more than likely do an extra pre-wiring. We don't run copper that much, but as long as you got a hole with a PVC conduit in a 3-inch PVC, you're gold. Just have a pull string through and you got an end cap there, you're sort of set. You don't need to run copper. Copper is expensive and you don't want people to come and steal their extra copper. Okay, so when we talk about pre-wiring, we're not really talking about running copper. We're only talking about running a PVC conduit and then running a pull string through and just capping it off. That's about all we're talking. And that has almost 10% savings, when you go to expand, right? Because these are capital intensive projects. So nobody wants to invest like 50 charges on day one. You wanna run it in year 1, year 2, kind of in that. And cabling, we sometimes do LAN cable in the ground, or we sometimes just put a SIM card on your first charger and it does its own thing with it, sorts of creates a hotspot for the other chargers. We've done it both ways. Depends on the cell signal and how reliable it is, and do we want to take the risk, or anyhow we are trenching it, let's just put an extra trench and run the data. Cabling doesn't cost us. In LAN cable doesn't cost that much. So small decisions during construction, but there's some thinking that goes into what we do. Let's see what else. So why as like I said, our vision has been to go behind the range anxiety problem. We want to solve that. And we also realize that as more charges get put up connected to the grid, there's a good potential for the charges to be used detrimental fashion to the US grid. So because we come from the technology background, we understand where the vulnerable points are in terms of security. So we always use network secure chargers as a OCPP protocol that we follow. And there's a newer protocol that's coming up in these chargers, which provides a lot more security. So we try to implement that. It is for the payment and also to control the chargers, because from our software we are capable of understanding. We have a bidirectional communication with these chargers. So if someone hacks into the network and if they're able to turn off the chargers, that's something we don't want to happen. Likewise, we don't want them to add on additional load back into the grid, because all these are connected to the grid. However we see it. And if we have 500 out there, all of them are connected to the grid. We don't want all of them to turn on by a malicious actor, right? So we are very careful in managing our security. We bring our own network, and all these chargers, like I said, go through OCPP 2.0 protocol. And there are periodic checks that help us understand what's going on, what's not going on, things like that.
Question I wanted to ask is, an apartment, they charge the customer, which makes them a power terminology?
Yeah, I'm not sure how your apartment complex. So if the apartment builder has provided chargers to the tenants who live in the, then they would just be passing on. Usually there is an operator there who handles the charging services. Yeah, I think so. I think she has, yeah, normally.
you build it. So it's not like a public charge where you build directly.
Yeah. Right. Right.
In this case, with the apartment complex, it's a little bit more complicated.
Yeah, I think even nowadays, even apartments, we tend not to use credit card readers themselves. They come with a QR code. You just flip open the phone, scan the QR code, and payment happens automatically. So that, yeah, that way, we're not, you know, yeah. If you have a swipe card, then it creates more, I guess, surface area for cyber attacks. That's the word I was looking for. So we want to minimize as much as possible. Right? We don't want to store any stripes or things like that. And some of the lessons that we have learned, I think I want to share with larger communities. Plan ahead, right? If you are a builder, you are building a new property or constructing, think of not just today but also 5 years down the line, because this, when your tenants come back and ask, hey, we want chargers in our apartments or in our property, then how would you answer at that point? So plan ahead is our suggestion. It also helps with pre-wiring costs and things like that, and it's an extra revenue stream if you are a developer, because some of the money goes back into the developer's account, right? Now what's the other one? Again, select your charges depending on the property. Hotels L2s are beautiful, they are sufficient, but if it's a highway intersection, gas station, you probably want a high voltage DC fast there. Home, definitely a single, right? There's no need for that. And then think of when you're working with one of these providers, think of the utility upgrade costs. You're gonna have to upgrade the utility, so factor those kind of things in there. And the technology is also moving fast. We already know wireless chargers are already coming. There are companies that are working on that. You just pull into a parking lot, and then it's not conductive. I think it's inductive charging is what they call it. No, it's not that mature. We don't have standards for that. I think it's still about 5-6 years away. But we're watching the technology. We don't know when it will make into the mainstream, because right now all the OEMs, everything starts with the OEM, right? If Ford does not have a car that accepts wireless charging, there's no point in having the technology, right? So we work. We sort of, when we look at what are the OEM plans, when are they going to release a vehicle that will accept wireless? So those two need to marry up. And right now, all the OEMs have gotten cars for plug-in chargers, for the conductive charging. So that market, I think, is gonna stay on for some time. And even on the DC fast, 50 kilowatt used to be a big thing, 5-6 years ago, even till this year. But now we are seeing 50 kilowatt sort of fading away. Maybe a couple of years ago, 50 kilowatt was like, wow, oh my God, right? But nowadays people are asking for 150, almost 3 times jump in a span of 2 years. So it's moving very fast, and we're talking about liquid cooled cables that carry 400 amps. It's a lot of power that needs to get pushed into the car, right? So anyway, so again, keep these things in mind when you're working with your service providers. And ultimately, customer is king, right? You got to make sure your drivers are happy. Nobody wants to wait. So give safe charging, short charging, make it happy and fun for them. So that's about all I think I had. Sure.
On the DC fast charge, this is kind of an engineering question. Do you simply take some line voltage and rectify and filter it and provide DC? Is it that simple, or? Okay, I was looking for John. Maybe he has a comment on that. Yeah, I was just curious about that. With some clamp-on amp meters of some sort.
Yeah. All the rectification happens off board in DC fast, but at a very high, and that's why you need fans, cooling, and protection. I think it's to do with cooling. Yeah, the fans are every 2 years the fans need to be changed, the filters need to be changed, and because they're out in the open, there's dust and other things that happen. So usually and these are all certified UL certified chargers, and they have pretty stringent regulation on air ventilation requirements. That's why they sort of look a little bit. Yeah. This is it. Yeah, you will find like racks and racks of coils, cooling fans inside. Yeah. No, no, not yet. Well, I won't be first though. Yeah. Well, I mean, see, unlike the gas, right? With EV, you can find out who it is. With gas, if you just drive off, you don't know who actually charged. EV isn't like that, right? You know who was there. Yeah, and they're very smart cars. Yes, sir. Sure.
One of the things that I noticed talking on your slide 13 on your I think it was your charger type slide. You listed DC fast chargers as up to 90 kilowatts. I think you're going to need a third category there for up to 350 because that's pretty common now. But I was curious about that, whether or not you guys also plan amenities near the stations in that category, whether, like picnic tables, shade structures, that kind of thing, or are you guys purely focused on just the site electrical and the hookups in the stalls?
So we got a couple of projects with gas station owners where all we are doing is just standing up the infrastructure. But because the gas station has already those amenities inside, so we really don't get into. We are developing a vacant land, this is just vacant land off of interstate. There we have to plan for sewer well, water well, and like basic amenities along with the charging infrastructure. So it really depends on the property. We have retail. We're putting charges L2s on in retail lots. That we are not planning for anything. Now, what we normally do is we don't put all the infrastructure in year one. We go with a plan of 4 to 8 chargers in year one. And we typically submit with the developers a development plan for that. And usually in year 3, year 4, we might plan a solar canopy or things like that as that property picks up and everything else is happening. Not on day one, but again, depend on where we go, what we do.
So the other question I had was, you mentioned you guys do pretty much all network chargers. Is that something I can have API access to? So context, I run a route planner for electric cars in my spare time. And one of the things that we have a hard time with is getting accurate, up-to-date station data to make sure that we're sending our users to good charging stations. Is that something that you guys manage, or is that something that you hand off to whoever's operating the station, or how does that work?
So typically, station utilization we share with the property owner. That's a little bit confidential, so we share with them. We have not been asked for API access by external parties, and I don't know what to answer you. Yeah. Yes, but it doesn't. So what goes on PlugShare is the location of the charger and the station information. Yes, the station utilization is, see, in the industry, station utilization is a very well sought after metric. Okay, because that determines the revenue generated, who's coming, when load happening, and a lot of things can be found out from that. So we definitely share it with the developer. We have it, but I have not come across that question. So I'll need some thinking around that. Yeah, yeah, right. OCPP is all we do. Yeah. And then on the utility side, there's open ADR for load shedding.
I have more questions. If you have questions, go ahead.
Oh, sorry.
So one, I guess, issue that I run into with charging is every charger is a different company and I need a different, tag or account on my phone or something. What are you doing to solve that problem so that I only need one account and I can charge anywhere in the US?
We are aware of that. So what we do is, that's why we do the QR code thing. QR code is just a flat page. You just pay and off you go. We are not wedded to having a account on our network. If you want to, you can. But I know other competitors, they require you to be their member to utilize that charger. And for us, it goes against our vision. I mean, really, we want to have people come in and pull in, charge, and not have to worry about, am I on the network, not on the network, I don't have signal. We want people to drive up, plug it, and off they go.
So you've mentioned 2D barcode.
Yeah.
Enable anyone to be able to use it?
Yeah.
It still needs to have
No. When you scan, what happens as soon as you scan your phone, your Android, iPhone, it opens an Internet Explorer, and that Explorer will tell you or will tell us which charger the driver is in front of, and all it tells is, if you want to, of course, you have always the choice to become a member. But if you don't want to, you just put in your credit card details and plug it, and we will know that, okay, this person's card has gone through, and light will lit up, and plug it. That's simple.
That's how it goes if someone is not a member.
If it's not, yeah.
Relatively easily.
Yeah. I mean, we don't see a need to. We're not behind customer data, so.
And then, of course, a lot of people that compare the experience that Tesla drivers have.
Right.
They don't do anything other than connect the connector.
Right. I think the technology will get there for the J1772. But right, I mean, Tesla, they have the luxury of owning the vehicle and their network, so they can marry those two together. But with the others, we operate on interoperability, and usually it's a little bit tricky to do that. But it's coming. When it will happen, I don't know.
Would it be possible to do something like what they do on the toll roads if you don't have the toll tag, where you just take a picture of the license plate from the station and send them a bill in the mail?
We do it for security reasons, not for charging reasons. Okay, we have capability to we put in cameras for security reasons, because we don't operate. We don't have a man physically present in these charging stations, so we rely on security cameras to help us. But as a business, we don't want to be in that process of just drive, connect, and go, and I'll come collect your payment. For toll, that's a different, government has a lot more resources at their disposal. We don't want to get into that at this point. Yeah, the email is up here, and yeah. And my email is is on my business card. My phone number is also on my business card. So. Yeah, you can have the. Can you please repeat audience?
solar systems where there's a component of local community ownership. Dallas, but Sunnyside, Houston, and Big Sun Solar, San Antonio said yes, are potential.
Yeah, we are open to talk to the what is the word, community solar systems, the whoever the owner is. We're happy to work with them. We don't have an issue. We have not done it, but we are willing to talk and see if we can. Yeah. Usually in all these, the some level of ownership, right? We only own the infrastructure. We don't come in as in our typical deals. We don't own the property. We don't own the land or anything like that. Now, if they own a site where they're operating solar panels, then we wouldn't mind putting up other infrastructure. Yeah. Slides will be available. Yes, sir. I think you have.
Yeah, is it available and where is it and how fast is it? Basically, is what I wanted.
PlugShare tells you the rating of the charger. Whether it come or not, it will know. I don't know. It tells you how many are there.
Yeah, they do provide up or down status for the networks that they have connections with. PlugShare does provide up or down status for the networks they have connections with, which isn't all of them. So
yeah, we participate with PlugShare. So whatever our plan with PlugShare allows us to provide.
Yeah. So
that is not right. What's proprietary is how much of what's not proprietary is the type of charger. Is it up or not up? That is not proprietary at all. That is necessary information for the drivers. Is it? Yeah. Is it in? Oh, yeah. PlugShare, I don't think tells you that. And that's why sometimes they let you make a member, because as soon as you make a member, you have the advantage of reserving your slot at a particular time, and you can get price signals. So there are pros and cons. Sometimes price signals can be sent to the driver saying, hey, the rate is very low now. Do you want to go charge yourself? It's up to the driver to figure that. And for that to happen, we need contact information of who to send to, right? And that's why you kind of need to be a network, as a account holder. So pros and cons, again, choice is all for the drivers. So did that answer the question, or I didn't answer your question? Yeah, sure.
So one of the things that we took a road trip to California and back, and we noticed that a lot of drivers, especially in the really hot areas of the country, those cable coolers had gone down, and so we got throttled to pretty slow. It's kind of two parts. One, what are the typical failure modes that you see on, especially the fast chargers? And two, is there any kind of like end tests that these things run? Pushing power to the cable with no car attached just to see if all the connections are still working, that kind of thing in the background to make sure it's still working.
Usually self-test can be, or diagnostics can be actuated by the back-end support people. Just like your modem, right? If the modem, AT&T modem doesn't work, we call them, they say, okay, give me time, I'm rebooting it, right, remotely. That can happen. We don't let our chargers do it by themselves. We just don't. But as long as they're managed remotely, we can make them start, stop, and go through the basic checks as far as the firmware goes. So the common, I would say, filters and electronics is usually where the what's the word I was looking for? I'll find it and tell you. No, in testing, we find that the PCBs fail quite often for that component. I just name beats me right now. Yes, sir.
I think when Metro presented here recently, didn't they say they were going to put solar and some lithium battery packs at the charge stations? I was wondering whether you might have considered such a thing.
We looked into solar panels. I think the current conclusion is, I'm an engineer. Current conclusion is solar panels by themselves cannot charge through a charger. Okay, so they generate very low power. Solar panels are designed to generate low power for a very long time, whereas car is a different animal. Car wants more power in a very short time. They just don't, line up quite well. What can be done though is use a storage technology where the solar can charge the storage technology, and then when use that to disperse through the charger. That is possible today, okay, or in theory and in both in practice. But the costs are way too, astronomical for that to happen. The storage technology costs have not come down yet. It is still expensive. I think storage costs $200 per kilowatt hour or something like that. So when you try to multiply that with, let's say we go to Electrify America and these gas which are 150 kilowatt, you now think of how much big storage that needs to happen. And the utilization on these charges is not, we don't see 24 hours these charges, like people lining up. That's not happened yet. So is it possible from an engineering standpoint? Yes. From a project economic standpoint, would someone do that? Maybe some, not maybe if you're a billionaire, I guess you can, but.
You could, and then disperse it into the cars during the day when it, and actually pay for your batteries.
Yeah, I think what he's saying though is that the utilization isn't high enough for that to make sense yet. Because you'd need enough people using it every day to pay for the battery to make that make sense. So probably for now, if you're not putting out the 350 kilowatts like Electrify America is, that's the really expensive electricity during the day. And so that's where the load shifting that a battery would give you would really save you. That's why like Tesla and Electrify America are putting battery packs at their stations, because they're paying the really high industrial, multi-megawatt power costs. Yeah.
The other thing that is happening from a cost standpoint is the utilities charge what's called a demand charge. And there is, we haven't paid much attention as residential customers. But what happens is they unfortunately treat a charging station as a commercial account and levy a pretty hefty rate for demand charge. Which is unfortunate because by nature of the charging stations, you will see peak loads during daytime, right? People are out on the road more often on daytime than at nighttime. And if utilities penalize the charging provider for that high usage, then all this talk of we want to, give more chargers, we want to give this, we want to have more EV, how is that going to happen, So there's a little bit of, so a lot of EV charging providers are trying to push back and educate the utilities not to levy the demand charges. When it will happen, I don't know, but that's also. Yeah. We see it pretty widespread. And utilities are regional, right? In Houston, you got Centerpoint. You go to Colorado, there are like only two utilities in Colorado. Edison in New Jersey, New York, that side. Everybody is utilities make ready infrastructure. They say we'll give you transformer, we'll give you everything. But I think if you really look at the fine print, what they want you to pay for is demand charge, which really kills a station. Yeah.
solved later with the transformer that the utilities are looking into supplying the DC direct. So the transformer and inverter will be sitting there. So all you need is your pedestals with the, so that demand will go away from the actual building that you're pulling from.
I hadn't heard that. Utilities providing DC instead of AC. Looking into it. Okay. Okay.
Yeah, I mean, if there's some utilities that are doing, we would like to talk to them and see what we can do.
Okay, so you look at the chat. You want to read that out?
Yeah, in the DFW area, the north side DFW cities are promoting charging multi-house and are yeah. So for Houston, the building codes are coming up. I think I wanted to put a slide, but I forgot. I think next year there will be a building code come out for Houston area. I don't think it's I think in the city circles it's been talked about, but I heard that the code will come out next year. Yeah. But otherwise, I mean, we go to some cities and they say you're gonna have to put a charger here. Fine. Now your parking mandatory parking count is gonna drop by 2. So it's very weird. Yeah. There's there's that aspect, because by code, by the city code, which is always local, the retail property owner has to maintain X number of parking stalls. And you go to some cities and say you're going to take up 2 of these slots, then you're going to have to create 2 more, and developer is not interested. After the fact, you can't go and create 2 more parking spots, right? So there's some education that needs to happen with the cities also. I guess everybody's learning. So the ADA, American Disabilities Act code, requires, at least in Colorado, we see they require you to have, I think 3 feet on either side of the stall for easement and other things. So some states are very pro in this.
Sometimes I've seen a spot designated, keep this spot, use the spot last so that it's first available for someone who needs an ADA space. Yeah, or something along those lines. So.
Sure. So do you notice that the chargers you installed, they tend to fail less when they're in the shade?
We haven't noticed that one. Yeah. I mean, L2s are fairly robust for up to 5 years. That's their sort of design life. HEAA, DCs, but we haven't died unless something major happens.
So yeah, thinking of availability of spots, I read an article the other day that there are now angels who go around and test chargers and make sure that they're working.
Yeah, actually, on our road trip, we ran into a guy from Porsche who was doing exactly that. He's driving a Taycan around the country, and he had just finished at the charging station we met him at, plugging the Porsche into every single stall and making sure it was, working with the car and everything was working smoothly. Because I guess Porsche really wants to make sure that their charging experience is premium. Yeah. So it's pretty cool to see. Yeah, that's another thing. I should have suggested it to him. But yeah, because you'll get
Chargers need better cooling, but more fans or whatever it takes.
Because you're finding that they're shutting down. So it's one thing if it works when somebody first gets there. It's another thing if it's still working 5 minutes, 10 minutes in. Okay.
Yeah. So how do I ask for locations? For example, like on a road trip, would have absolutely loved chargers at the highway rest stops with the playgrounds for the kids.
PlugShare is currently the app where almost all the charging stations in US are broadcasting themselves. The other location is AFDC, I think it's .gov.
That's where I can find the chargers that are already there. So
Uh-huh.
I can say, I want a charger here.
Like you mean here?
Well,
As-
find a spot, I would suggest.
How do I get past-
Oh. I guess email me. uh, I don't know. That's a good question. Yeah.
Property owner.
Right.
Say we have something.
Right. So normally you can work with your property. Yeah, you're right. Your property owner. You can tell them to call us, or have us call them, or because ultimately, Yeah.
Tell them what you could do. for
right.
them. Whereas I just say, I'd like to have a spot, but
Can you call Fast Park up at IAH? Fast Park and Relax up at IAH. They have 10 slots and they are always full.
always full. So they have some. They didn't have any, so they have them, but they're not enough. Okay, now that's an interesting problem.
Okay. Yeah, we'll talk. We can talk to them. Fast.
Fast Park at the airport, IAH, Intercontinental Airport, Houston. Yeah. Yep.
So you talked about the different models or brands of cars that can use your chargers. And you had a Tesla pictured. So do owners have to come with their adapter though? Or I guess what kinds of charge?
Do you install Tesla?
Yeah, we very less. We do, but very less. Typically, yeah, I think it costs like $80 or $100 to have a Tesla to J1W72 connector. So if you have that handy in your trunk, just slap it and off you go. You're done. We on some properties we try to put a connector, but for theft and you don't want exposed connectors, and it's not an ideal situation for us to provide a connector because there's nobody there. It's not like you can go and knock somebody and, hey, give me the connector, right? So I guess today's suggested recommendation is to carry a connector. We usually put dual port, and both are typically J177 connectors. We talked about having maybe one of them as a J777 to a Tesla connector, so it's already Tesla ready when they pull up. This is for level 2. Yeah. We wouldn't do it for. Because these connectors are different. High voltage connectors are different. The technology is different, and the risks are different. So.
I read that South Korea is going to be the first place to get the DC fast charger adapter between Tesla and the J1772 DC.
EVgo and Cracker Barrels are putting in all three. They got J1772 and not Chatamo, but they're also now with putting in Teslas. I got a question. All these parking spots that you showed on all your pictures have short parking spots. What happens when RVs and trailers start to happen?
So these are all what's called passenger car or light duty vehicles. The other class that is starting to pick up is the medium and heavy duty vehicles for the truckers, the 18-wheelers and RVs. So they wouldn't generally go in the retail locations. They wouldn't. So we're actually talking to Lowe's, which Lowe's gas stations are generally for 18-wheelers, and they already have infrastructure for high voltage stuff. So we would put high voltage charger, like DC heavy HVDCs are generally fine.
Yeah. So when you're talking about it, the Love's gas stations for the trucks, are you just talking about the same type of DC fast charger that you do? Okay.
As long as the trailer can accept a CCS or a channel, which I think they do.
So in my case, I'm pulling a camper trailer with my standard light duty vehicle. So when I get to a charging station, most of the time I have to unhook the trailer, plug in, and then spend 10 minutes after I'm done charging, hooking the trailer back up and then getting back on the road. It'd be nice if there was a pull through spot, to do.
Definitely.
I think they will come. To me, it's picking up. It's a function of economics and land, other things, right? Because we work with developers, and if they are willing to let us do that and there's enough demand, then that shouldn't be a problem. Yeah.
Suggest to them that they have an island in the parking lot that they could put a charger there where somebody can come up along the side of the island, as opposed to having a parking spot that a vehicle with a trailer on it can't use. Yeah, that's the thing.
I mean, everyone's building electric pickup trucks now. So you got your F-150s, your Silverados, Rivians, the Cybertruck. Everyone's going to be towing, so pull through spots are needed.
Yeah. Okay. So more questions from folks. Nothing else in the chat. So it really hit home when you were talking about the hotels. So I just got back from being in New Jersey yesterday, and I was visiting some cousins, and some other cousins were staying with them. So I stayed at the hotel, didn't have any place to charge. I got a car on Turo, Turo, which is kind of like Airbnb for cars. And I got a Toyota Prius Prime. So it was capable of charging. And so I actually charged on the outlet right by their front door at my cousin's house during the day, even though I was staying at a hotel, which to me should have had, at least level 1. I mean, but there was nothing there at all. They weren't equipped at all to let it charge.
I think it's happening. I wish it would happen. I think the EV people, they live in one world and the rest of the others live in another world. I think that's a conversation we feel like when we have some conversation. Because we talk to the hotel owners like, yeah, nobody's asked me for EV cars on our property, so why would we want to have many? Like, okay, so you are in a different
The problem that they run into now is that the people with EVs know to use plug share and whatnot to find the hotels that already have chargers. So they're not going to the hotels that don't have them yet and asking, hey, why don't you have a charger? They're just going straight to the ones that already have it.
Yeah, it's kind of a chicken and egg kind of thing. But I was happy when with the family we drove, we were in New Braunfels and we were staying at a motel, and we asked, and they go, yeah, we had somebody just use the one. A lot of hotels have, covered drop off at the front. And they said, yeah, just at the very end of it, pull over to the side so you're not blocking the whole width. And there was an outlet on the side of the building that they had previously told someone else to use. So it was like, good. I'm glad I wasn't the first one that, this was well over a year ago, probably 2 years ago. So, hopefully that word is getting around. Well, this was a case of, I brought my own cord set and there was just an outlet on the wall. I could have, I didn't. Yeah, that is a better way to go. Yeah, actually. And then nobody's gonna, unless they're really mischievous and they have wire cutters with them that can handle well, there's that mischievous too.
We'll lock the charging port now. My ID4 locks the charging port while it's in use, so you can't steal the cable. And you can even set it where it won't unlock it till you unlock the car.
Well, that's the thing. Yeah, you just never know about folks and things like that. So yeah, parking on the cord. Yep. So as I mentioned, everyone could see the screen. There's email address there. And so that'll go to either you or one of your other family members. How many family members do you have in your company?
Well, we are partners with two, myself and my partner. So it's two of us. Yeah, two of us. Yeah. Well, I mean, no, we got a team locally here. We have an office serving Asia market in India. That's kind of where we got, because we were working with the OEMs there in the power distribution sector. But we do engineering here. All of permitting and engineering needs to happen here. So we kind of do it.
Because I was really glad to hear that the engineering work is done, because there are a lot of companies, and it's needed, that they will just take charging equipment that is and just put it somewhere, just like any other construction can, put a post in concrete in the ground or something, that you actually do the engineering work. Because I noticed you mentioned there about being sure that harmonics were not going to cause problems with the transformer and other things to have, so people have a good experience. Because as we're saying, we're finding folks that, they may be able to start charging, but 5 minutes in, you can have a problem. I hadn't heard that problem about cooling cables having the cooling fail. So I know that these higher powered ones, both Tesla and non-Tesla types, are using cooled cables, but I had not heard of situations where the cooling would fail, which it's like something that's capable of failing. Yeah, somewhere it is going to fail.
It's not just the Electrify America stations either. I saw an article with you remember the heat dome in Oregon and Washington? The superchargers were having this happen on the V3 superchargers too. And the cooling would throttle them back to like 50 kilowatts. And, you'd spend a whole lot longer charging on that one.
Oh, yeah. So in one sense, of course, good that they put the sensors in so that they keep it safe to do that, as opposed to let's not have a fire because, yeah. Yeah. Because way back when in the 1990s, I did melt lead posts off of lead acid batteries. So I have seen a puddle of lead from, that electricity can make some good heat. And yeah, battery doesn't work so well when one of the posts is just a flat puddle after that.
And that's partly why we also only do network chargers, because we want to have our eyes and ears on what's going on, right? And these are all all over Texas, so you can't physically have someone walk every day or drive every day. So yeah, that's definitely there. And like I said, we do local engineering here. For Colorado, we partner with a licensed company that is capable of stamping in Colorado, because these need to go to the city, which means you need a PE. I am a PE myself. So you can't just do any monkey engineering and just get things done, right? So you're going to have to go through the proper permitting process. So because we operate in both the states, in Texas, we can do it ourselves, but in Colorado, we got other partners who can at least cross-check what we do and then put their name, do it that way. Yeah.
Professional engineers.
Yeah. Right. Yeah. So it's done with safety in mind for us. Nothing else is important.
And as I mentioned to you at the beginning, please come to our monthly meetings, either in person or online. I mean, we want to grow the group as more folks, want to interact and both ask questions and offer information and so forth. So, all right. So we'll switch over to Bill now. Thank you very much.
Sure.
Well, yeah, let's go ahead and pass some of these out to folks here. Yeah, so that I'm gonna go ahead and so that way people get directly your email. And so very good, because yeah, without businesses pushing things forward, I mean, do we really want to be at you showed some equipment, car makers up there, just don't want to be solely at their mercy and so forth. And we know that Electrify America is really being pushed by one of the car makers. And so it's good to have local businesses that are going to be responsive to local needs. Yeah. Mm-hmm. So yeah, let's aim the camera at Bill now. Well, I've got to move the little thing here out of the way to. Oops. Let's see. Can we make this a bigger size? Let's see here. If we go to, nope, that's little. I don't want. That's not working right. Say again. Stop screen share and just go to stop share. Okay. All right. And so We go to view speaker. There we go. And well, we're still gonna have these folks over here, and then my chat disappeared. It's under more, I think. I wish they put it, chat to me is important. Oops. I wish they put it more, instead of under the dots, put it somewhere better to get it. Oh, come on now. Come on, there we go. I think that'll let us, well, move that up again here. Okay. There you go, Bill.
Okay, shall we go ahead? Okay, thanks everyone. Somehow broken batteries come my way. This is this was a 10 kilowatt hour battery pack. There were 4 of these modules. It weighed in excess of 200 pounds, maybe 275 pounds. And I took it apart. This is a bank of 60 cells, lithium cells, 2865 geometry. And I could pass this around. This is the broken bank. It's down to 0.65 volt between the copper and the nickel. And if you get it examined, how they've spot welded the nickel plate, the silver plate, to the anode cathode. I guess that's the right word for batteries, right? Anode and cathode, or plus and minus. Yeah. Went bad. I want to pass around the battery management system. This is one I've dealt with a little bit. Battery pack, maybe I should be, are you following me there? This is for a 24 volt battery pack. And so there's 8, this is a 12 volt battery pack, and there's 8 banks would make 24 volt. So there's 9 wires that go to each lithium cell. This has communication, Wi-Fi. It talks to my iPhone, temperature gauge right here. And this thing is essentially a switch. When the battery voltage gets too low, the switch opens, or when any cell, I should say, gets too low or too high, this switch opens and cuts off the load to protect, here, I'll start over here, to protect the battery. Because you've heard stories where if the batteries get too low. Now this one I'm passing around is 0.65 volts. I assume it's not going to catch fire. Anyway, so it has the nickel and then the copper. And I assume that's a conductivity thing, because the power, is on the plus or minus sign of each of these 60 cells. It comes out and then goes to this bus bar that connects it to the next bank. These 2 banks are at 3.6 now. As I mentioned, that's 0.65. And that's kind of my story. And so I have 4 of these now. And I have a choice of making it into a battery pack that's not 16 in series, but 15 in series, which means the voltage would drop by 3.6 volts. And you can get a battery management system for 15S. Having 3 more of these, I'm perplexed with the problem. What I do, try to bring the whole battery back, or forget this, salvage the batteries out of here for another project? Or do I make a 12 volt battery pack, which means 4S, or do I do a 24 volt battery pack, or what? So those are some of the decisions at some point I'll have to make. Any questions? That's essentially what I wanted to mention. Yeah. No, I don't. I have no idea. Unfortunately, documentation was not available. So we haven't a clue why it failed. Oh, really? Yeah, but they're down to, everything's down to 1 volt now, so they're kaput, wouldn't you say?
No, because that one cell won't charge. So one can't charge either because of that battery management system. You won't allow them to go up.
So that people catch that.
Try pulling it apart and seeing if they're all bad, because you're gonna have to charge each one separate after that. I bet you have one cell that's gone.
But are you suggesting that, yeah, maybe one is bad? I could test it by trying to charge the one at a time, the remainder, and they would come up and they're not kaput?
Maybe not.
Yeah.
Because I was doing the same thing with my volt batteries. I would find one out of the whole 12-volt pack was pulling everything down. So, and then there's 3 pouches in each one of the volt battery packs, and one of those could go bad out of those 3, which would pull that one cell down. But the other 2 pouches were good.
Yeah, I mean, to have simultaneously things all go bad is unlikely. I mean, over
That's
time,
correct, yeah.
more likely to have,
Yeah.
one go bad, but
Yeah.
yeah.
It was a 20-foot container with 16 panels, place for a guy and his family to go on the weekends. And, he has an 80, it's interesting. The charge controller accepts up to 600 volts. That's unusual for a charge controller. This one operated at 270 volts. And we revived, he had 2 of these batteries, and we got one going and took it back out there last weekend, and we're making the connection to the charge controller, and there was a huge spark. We said, wait a minute. So I'm sorry. Well, so we spoke to the factory. These were Schneider. You used to work for Schneider Electric, ABB. So and there should have been a circuit breaker in the loop, and so we're going to install a circuit breaker, and hopefully things will come back to life, and he'll have power at his place.
So when you say container, you mean the container was used for housing?
Yeah, it's 2 adults and 2 kids, and they go out there just to recreate on the weekends. And
I thought maybe it was a powered container for shipping, like for running air conditioning or cooling or something in a container, because there's a lot of containers and things do that. But it's containers for housing. Okay.
yeah, and not only that, City of Houston built 17 containers that have 16 panels, and I would not be surprised if all 17 the battery pack has gone south, and it's a lead acid battery pack.
Oh, well, yeah.
And I'm helping teaching the high schoolers how to use a voltmeter, which is so
As Sagar mentioned, things have to be maintained. I mean, it's not, things just can't be built and just put out there and, expected to last forever.
So I have another question, maybe directed to John. I visited some solar farms going in, 300 megawatt, 450, 600 megawatt down southwest of Houston. And I visited a new transfer station where they're to service one of the farms. And the guy said they were putting in a huge lithium battery pack. And I thought, well, okay, this battery pack can't be large enough to take the offtake from the solar farm upon a grid failure. And I was wondering, John, whether is it typical that transfer stations?
So there's actually a number of reasons why you would put a battery pack at a power generation station. Only one is load shifting. And for that kind of purpose, you would need a huge battery pack if you needed to store your solar for overnight. More likely what it is for grid momentum. So for your standard generator, you have a giant turbine, you have a lot of mass that's spinning that keeps the grid frequency right at the exact right frequency. And there's a lot of momentum that keeps it there if the frequency starts to drip or dip rather. Solar doesn't have that. There's no momentum that if the frequency starts to drip, it drags on the spinning components, and the spinning components bring that frequency back up. So often the ability to provide frequency correction back to the grid is something that the grid pays for. And so that's often why they have battery installations that maybe don't do a lot of load shifting, but they have a buffer that can, force the grid frequency back up or down if it's getting too high.
So a buffer meaning an electronic buffer.
Yeah, exactly.
Electronic.
Another reason. There's also the ability to take, you usually put in too much solar and not enough output, not enough inverter. So at the peak, it's, you peak out your inverter, you're wasting all this power at the top of every day. So you could dump that into the battery and then push it out when at the end of the peak of the inverter curve.
Oh, I see the sizing of the inverter.
Yeah, it's some kind of incredible.
Can be optimized with the.
I mean, are you talking about load clipping?
Basically, but it's the opposite. So when the inverter comes on, it ramps up with the solar output, right?
Yeah.
Okay, the solar output keeps going, the inverter has this much power. And so you're wasting this top part of the output of the solar. Okay, so you push that into the battery and then output it as soon as you can when you get it done at the other end of the curve.
I'm going to visit again and ask more questions. But I do have a question. You stated that I lost my train of thought. Oh gosh, sorry. Oh yeah, so I understand the grid can lug down a rotating generator because of the demand and the load, and it slows down, the frequency changes. Is the same sort of analogy occur when the grid demands too much of the solar farm? Or I don't understand, I mean, how the frequency could shift when you have a solar farm, because yeah.
Spinning. You can, if it needs to produce more frequency, equal, but frequency is being pulled backwards from all the rotating machines. Capacitors are another way to do it. So cap bank would fix it as well as an inductor bank, depending on which way you're going on that. So a battery, I've not heard done that. You can probably push it and raise the frequency on the output with a different inverter. I've not heard of being able to push, it would have to have a separate machine to push that in
Separate
frequency back
electronics.
up.
Separate electronics.
Another way to go also is to have way
The
too
young
much.
engineers chiming in.
No, check this out. They're all putting in inverters that peak out and then come back down. What if they put in a smaller inverter, had way too much solar, and let the solar go into a battery bank and then push the solar all day, every day, 24/7. We get rid of all the duck curves and all that shit that happen. I'm sorry. That happens when it's an expensive battery bank, but you're buying a smaller inverter.
Right, exactly.
So there's
cost of
a better payoff there because the inverter is only going to be warranted for a certain amount of time. Batteries too. So it may be something, especially if there's in Hawaii, when you have a small island and you're trying to feed into a bigger,
Right.
too much solar type situation.
Right, exactly. Yeah. Yeah. Because you were talking about wasting that upper part that's above the inverter's capacity, but you also have to optimize your costs for your waste. Now, you, like you say, add a battery and now you've time shifted.
The reason they put in way too much solar is so that the solar bank's only going to last, what, 20 years, 30 years, guaranteed for that output. No, the solar's, the PVs themselves. The solar cell is going to last 20 years and it's going to be degraded by 20%, 20%. So that's when the inverter is not going to shave off any. It's going to be a perfect curve. So what are they going to do? Go replace 10% of the panels so they can get better output?
Right.
Yeah,
No,
so they're
it's-
not.
Or wait 20 years for the solar to get derated, which is not nice.
They're planning on it, but Now they put this battery bank in that we do anything. Won't be able to pull in any power because it's not shaving off any at the top in 20 years.
Right, yeah.
Maybe they're just 10, 20 years.
Certainly, yeah, newer equipment. I mean, we've seen wind powered wind farms because they've used the optimal locations and now you can put better wind turbines in. And so, yeah, the same will happen probably with the solar. Yeah, you've got to engineer it for a certain amount of degradation. What size inverter do you want to plan for over the average output of that array? Yeah. So, okay. More comments?
I got another comment very briefly. There's been a little bit of talk about, now that all the car companies are producing electric cars, how do we, the HEAA, reinvent ourselves? And I had this thought coming over, assuming fossil fuels are, demand is going to drop over time due to more EVs and you know, Lord knows there's a huge amount of talk on NPR about global warming now. It's out, right? And it just occurred to me that batteries, you know, I tell this story. This is a wonderful story. I used to have lunch with a guy that worked from Shell, and I was just getting into photovoltaics at the time, and he kind of shudder a little bit when I started talking about renewables, right? So I said, Joe, henceforth, I'll call fossil fuels ancient stored solar energy, and I will call wind power recently stored solar energy, and photovoltaics immediately stored solar energy. Given that storage is hot right now, and only going to get more pervasive, you know, it just occurred to me that the name that the HEA might morph into might be reflect the fact that you know, do everything electrichouston.com or some weird name like that.
Well, we've all seen, yeah, a lot of things are changing. I mean, I've been reading situations where they talk about homes that now have natural gas heat, maybe switching to electric because you can use it with ways, especially Houston, you know, there's as much or more load cooling as there is heating. And you can't burn gas at a home to cool it. So why not just have an entire electric heating cooling system and so forth. But yeah, exactly. The nature of things have changed. We have lots of folks who like building their own kind of homebrew vehicles. And, you know, we've seen those over the decades and so forth. Yeah. I mean, there have been a number of companies that have come and gone. I mean, back in the mid 90s, I had a Jet Industries Dodge Omni. The unique thing about that, it was, as I mentioned, lead acid batteries, and they of course put a big out of a forklift. But the interesting thing about that was that it had heat in it because people and Jet Industries went out of companies. And so, yeah, so things for this club have changed, obviously, over the years. I was real excited to have 2 Ford Mach-E's at our National Drive Electric Week event there at the elementary school. And along with other bikes and things, I mean, some that we've seen for a while, like Nissan Leafs and others that are, you know, brand new ones that are out there. And right, the Porsche was there. And
We have taken a new URL for HEAA. I mean, there was some talk about changing it, right?
well, the national organization, I haven't seen anything and I haven't taken the time to look and see what the national organization has done. It's about changing auto to vehicle. Just to reserve it, I actually looked up, and HEVA.org was already taken by the Humboldt electric vehicles. That is not available, but writing out Houston was available. So I just reserved that because it was $10. Yeah, writing out the word Houston as opposed to using the letter H. So instead of HEVA, it's HoustonEVA.org. And so Colin just tied that to our existing website. So if anybody should happen to be inspired to type in HoustonEVA.org, it'll take you to the same information, which will give, as I mentioned in the emails, we record these meetings and we make the slides available for folks. I always clear that so that nobody's surprised who comes to speak. We have members who'd like to catch up on things later. People aren't available. Yes. So up in the chat, another thing a solar plus storage system can do is reduce the interconnection cost, similar to a demand charge in reverse. A smaller inverter requires a smaller grid interconnection, transmission line, et cetera. And so, yeah, that's another thing about how much power you need at a certain location. Obviously, that besides how much copper you need and things like that. So if you can have a smaller interconnection, you can have less copper, maybe less digging, or maybe reduce or eliminate at all, just use existing infrastructure if it's within the capacity of it, as opposed to having to dig and all kinds of power. If you can make do with what's already available, that's obviously a big cost saving. And that's what, of course, most people do at their homes. They're using regular 20 outlet. All houses have 240 coming to them, and it's just a matter of running some wiring around your house or something, and you can charge it 4 times the L2 rate as L1 rate generally. But yeah, so in terms of, we're talking about how many kilowatts are at some of these DC fast chargers, certainly reducing the interconnection cost, maybe by putting some more expensive equipment on location, such as with batteries or something, can reduce that interconnection cost. Somebody was telling me the other day that they had a friend who was going to put a grid independent system on their property because they got the quote from the utility to run power out to where they build their cabin was going to be like $25,000. So it's like, well, just put that into your equipment instead. That's exact example of this, reducing the internet cost to zero. In that case, that person just said, hey, we're just going to go completely grid independent and not have a electric bill, because that initial cost to just get the wires there is just going to allow the electric company to charge them for electricity every month.
Permit issues with that, because in some states in the past have house is not considered inhabitable if it doesn't have electricity or water. That's right. And it's more of a city code too. If you go and shut your power off, they can come condemn your house.
Oh, wow. Now, I've never heard of that variety of things. Interesting. Yeah.
If you're not connected, you don't have power until they change the rule.
Yeah, they may be out
Until
in
they
the
change
country
the
somewhere.
writing.
Yeah, he may be out in the county or country somewhere where it doesn't matter, where they have co-ops that he could join also,
Right.
if he had wires to his house. So
Yeah. And in some cases, it's a matter of updating rules to reflect the new reality. I mean, we've also all heard how Tesla sometimes has to charge per minute for people charging their vehicles in certain states because they're not allowed. They're not a utility. They can't sell kilowatt hours. They can sell parking spaces by the minute. You just happen to be connected and getting some juice, but they actually have to do it by time in certain states. Is it? I've kind of lost track.
plug share and everything is so expensive here because they do it by time.
Yeah.
And what's bad about it is, what's that? Charge point has 2 plugs on it. You plug one car in, you're getting 7.2 kilowatts, and it's whatever charge per minute. You plug 2 cars in, each car is getting 3,600 instead of 7.2. So that cost just doubled. It's like, oh no, go unplug.
Yeah. Yep. Exactly.
I don't understand why they did it that way, because see, technically level 2 chargers can be rated up to 20 kilowatt, right? So there's level 2 demarcates at 20, and anything beyond 20 is considered technically level 3. But most often found level 2 in marketplace is 7.2, and if you go to a dual port, it splits in half. I just don't understand why.
charge point. You can buy a charge point that has 2 chargers at, or you can buy one that only has 1. And that's where it divides. It's how much power you have available to plug into the.
And it's also going to depend on what a car can take. So when you say that L2 can theoretically, be built to provide 20 kilowatts, that doesn't mean that most of the cars out there can actually accept. Right. And then DC fast just is an entirely different story. Right. Right.
I was just gonna say, that's probably just, the whole copper is expensive rearing its head again. If you only have a 6 or 7.2 kilowatt charger, you don't need that much copper in the wall. You don't need to upgrade your building's electrical service. Plus, you get to advertise that you have 2 chargers, instead of just 1.
The building guy doesn't know that it's going to do that. He doesn't drive the electric car, so he doesn't know that, when they're putting it into this building, that it's going to actually cut it in half. Or he's only got a breaker that can handle a certain amount. The breaker panel can only handle another load of whatever. And they don't want to overload it. So.
Right. Yeah. So anyone online, feel free to type questions into the chat or comments, of course. We love seeing interactions with folks on Zoom. So that was great, Bill. Yeah, getting to know what you've been doing with batteries, and glad that John brought up some things that you can now look and further your research along the lines of. Well, you were saying there's spot welds and things in there you have to fight with. Yeah, it's can be kind of.
Yeah, what's the capacity overall?
This 4 of these modules, that being 1 of 4 was 10 kWh. And I can't tell you what the amp discharge rate was. I don't know, allowable amps.
So one of these would be about 2.5. So this set of 4 is 2.5. So this set of that you have with us would be 2.5.
This set of 4 is 1/4 of the size of the big thing. And I might add that it is what it is, right? And he may buy a couple of 10 kWh batteries. He may, we haven't proven that the good one is good yet. Yeah. We'll see. And John, thank you for that suggestion that they're themselves bad in that.
So it's different construction than the ones you've taken apart?
You have to cut each one of these between all the dots.
6 spot welds on each.
Oh, not even a straight cut, but a
Zigzag cut. Straight this way. And then test.
So you still get to throw it away, but now you know that it's probably mostly good.
I mean, there are 950 cells in the whole pack, right?
That's quite a number. And of course, we've all been seeing articles about the batteries in the Chevy Bolts all being replaced. And that has to do with, I guess, 2 particular manufacturing defects, which if they coincide in the same spot is what causes the problem. And
whenever they tell me it's ready, coming from Japan, so who knows when that's going to happen with all the supply chain.
right, I mean, they need to make quite a few of them, and everybody's got to kind of stand in line to get their replacement battery. Yeah.
Story about my Tesla Roadster. That battery is dying. It's a sad thing to hear because it beeps at you every 2 minutes. It's dying slowly. And so there's around 6,000 of these cells in that battery pack. I have sent it back twice to a company that will take out, the battery and work on individual banks. And they usually turn up 2 or 3 cells that are bad, and they replace, I don't know that they are repairing, but they replace a bank at a time. So they'll replace that bank probably. And that each time that happens, that costs money. Yeah. So because I'm shipping it to Tucson to get that work done. Tesla does not do that work. So I'm waiting on I gave up on doing this replacement because I'm going to decide, well, I'm going to just put the money into a new battery pack, an entire new battery pack. So this is it's a 10-year-old battery, but this is the hard truth about EVs and batteries, you know. Yeah. It's true. I mean, it was basically experimental. I mean, in a lot of ways, there was only 2,500 of them made, and I'm saying it was 7 years, I believe. Yeah, I believe that's right. And it lasted way more than 7 years. It lasted close to 9-10 years. But you know, when it goes down, it takes the whole system with it. The battery management system is the culprit, and it's protecting, or it assumes it's protecting the whole battery pack. Yeah, but it's a sad thing to witness.
Anything else that folks want to bring up? We're almost at 8:30. This has been fantastic to hear things. And like I said, we want to see you here. You see what kind of interaction you get going. And so you can tap some people's brains, and yeah, that'll help your company hopefully make good products and help get things out. So we got something else. Currently heard on Fully Charged that Tesla might be using the Blade battery currently being used by BYD in the Chinese made cards. Any other confirmation? Well, folks may know that Tesla, of course, built their factory in China to supply that part of the world. And I think they went into it thinking they were going to use certain battery chemistries that they were used to using. But then once they got supply chain in China, they went to the lithium ion phosphate, iron phosphate. That's what I'm trying to say. In their
So that's all. They said they were not going to produce them for anybody else, but that's where they're going to stop the technology so they can build up real fast.
production in China.
And so they're not going to allow lithium, magnesium, cobalts. They're not going to allow them to do it.
You're saying the materials out of China, they're not going to allow?
No, they just stopped all the technology. So everything at that point had to be lithium polymer cores. So everything out of China.
It's a form of protectionism.
Yeah. Everything out of China won't have these type cells in them. They'll have pouches.
Oh, okay. That's what you're saying. Yeah. Because there's different aspects. I mean, we know that there's a certain amount of environmental problems with refining certain materials, which go into batteries and into other parts of electronics. And China is willing to do that. Other countries aren't. And so China ends up with a market to itself for certain materials. And then, yeah, in terms of then technology for batteries, and then they specialize in certain ones. And that's why I say I think Tesla wasn't planning on going with the lithium iron phosphate. But then once they got Chinese suppliers for certain things, they said, oh, our standard range car still has the same volume for a battery, and we can fill that volume with a cheaper battery and build standard range cars for the Chinese market. So they're doing that. So back to the question that was asked about using the Blade battery currently being used by BYD. So I'm not sure the characteristics of that, but as I bring up about what batteries are available through Chinese supply chain. So if you've got a factory in China, rather than import things as Tesla did when they first started producing cars in China, they're going to more local suppliers. So that wouldn't surprise me at all that, once they're in that Chinese supply chain discussion and there's anxious companies that want to supply Tesla's factory there, I'm sure they'll make attractive offers, and then the Shanghai plant from Tesla will use.
That they're talking about?
I'm not sure myself. I mean, being used by BYD, Blade doesn't say chemistry or anything else. It's not a chemistry, it's a form factor.
Yeah, Dave, can you hear me?
Yes, go ahead.
Yeah, it's a form factor. I don't know what the chemistry is, but it's actually the shape. It's long and flat. They call it a blade battery. It's a form factor.
Okay, long and flat, as opposed to a more equally sized pouch or something like that.
I haven't seen any dimensions on the thing, but very rectangular, very long. It's like it goes the whole width of the car.
Ooh, that long. Wow. Okay.
Yeah, that long. Again, I don't know the dimensions, but I saw a little picture of a diagram, not a diagram, it's actually an actual installation, and they showed these things, and they were quite wide and rectangular, not a pouch, and obviously not cylindrical.
Yeah. Well, I can imagine that if when you're trying to wire up a lot of cells, even if they're not cell shaped, that if you had something that says the whole width of the car and you just ran all your connections along one side of your battery volume, you've simplified all your connections rather than snaking things back and forth to make electrical connections. So that is interesting, but I guess nobody here in the room or online is able to confirm or deny. Oh, Bill's looking it up. All right.
Hold this in front of the camera.
Sure. Yeah, bring it up to the camera. Yep, there you go. So that is telling us what the blade shape is like in a way. I mean, there's no quarter in the picture or penny or anything to judge the size of it by. Well, I mean, part
like a block, like we're used to seeing. They're like this. There's 96 of them, I guess.
Yeah. Well, of course, manufacturing is one of the things that you have to refine to help bring the costs of future electric cars down. So it's maybe somebody's innovation is to use this form factor.
Yeah, this article right here saying that they did nail penetration tests and they overcharged it by 260%, put it in a furnace to 300 degrees, and they're not getting fire or explosion, or they didn't get smoke out of the nail penetration. So it's like an iron phosphate battery that's as safe as possible.
Yeah. Okay. And yeah, if it can reduce production costs and such. So, all righty, we've come to 8:32. So next month, the second Thursday is the 11th, Veterans Day, but we'll still have a meeting. In fact, I'm kind of hoping that maybe some folks who normally have to work, since it's a federal holiday. Glad to see you here, Jason. Not today, not being a federal holiday. That was Monday, but the fact that, of course, they may have you working holidays and stuff anyways, because those folks up there in orbit, they stay up there 24/7, 365. Including Mark, who gets to stay, a year now. So because the Russians decided to make a movie in space. So that's a whole nother story. Yeah. And Mark and his cosmonaut cohort there now get to stay a year, and they'll actually beat Scott Kelly's record. But anyway, yeah, good stuff. And so I bring up about, next month, and what we really want to talk about, I don't know if you've heard, some folks have heard, is towing next month in November. So I've not yet gotten a hold of Mike Zutek, who of course is really big on towing. And I know that there's been some other contacts with other folks. In fact, when I was out in West Texas charging, I saw some folks with a small, kind of similar to what Mike Zutek has, camping trailer, and they had disconnected it. They had it off on the side of the parking lot so they could go over and charge. And it was a father and son, and I got to talk to him a little bit. Yeah, so we want to talk about towing, and Emma, you had a suggestion. We'll see if your suggestion comes through, I guess, for a speaker. Yeah, and so, yeah, so something else exciting. That's all I'll tantalize everyone with. Yeah, eyebrows going up and down. That's what you get for right now. But yeah, towing is what we want to talk about. So we'll see what kind of format we want to have. I mean, I think this is great when we're talking here. So I don't know, maybe we need more microphones or something. I really appreciate Robert Powell donating this microphone and the camera to help us be able to continue to do hybrids. And as I've mentioned before, we're just going to continue to do hybrids. So if you can't make it in person, jump online. If you can't do either, then you get the recording and then you can't ask live questions. So, all right. Anything else from folks online? So this was good. We got to use the computer room here for the first time. And hopefully that'll continue as we get this free space from TXRX. I'd like to thank them again as well. So, all righty, everybody. See you next month on the 11th.